All right, well, welcome everyone to our latest Insight interview here at Site Leaders Connect. I'm very excited. Today we're going to have talk a little bit about computer science and what it actually looks like and how it can support our students with David Platt. So David, could you please introduce yourself and tell us why you chose to go into education and why are you interested in computer science as well?
Well, I kind of have an interesting story with that because I mean, I love students and I love kids. I love impacting kids and I love working with kids. I think I know I get a kick out of always just working with them. I think because a lot of the times they crack me up, and I work primarily with high school kids, and then I've also worked with middle schoolers. And I actually say I have to say I love middle school too. It's such a challenging age, and those kids really are really cool. So I started out in education as a world language teacher, and I taught German for 16 years. So I always had computers as part of my background, and I did computer applications, and I taught those types of classes. And then it migrated and turned into computer science, which is what I'm currently teaching now. And I'm not teaching German anymore, sadly, but I am teaching computer science, and it's something that is a huge passion for me to see all students be able to do some aspect of computer science and be able to have that that understanding of computational thinking. I really want to argue that there needs to be 5 C's in the 4 C's, and that 5th one needs to be computational thinking, because
I like that.
Students need that.
Absolutely. Well, yeah, thank you for that. I like what you said about how all students deserve computer science. And so that's something that I'm interested in is, those that don't have any computer science background. I mean, they're coming to you as high schoolers or middle school as well. And if they haven't had computer science in elementary yet, because that's just now starting to hopefully roll out soon in our state at least, and across the nation, how do you do that? How do you make computer science work for all students? What does that look like?
Well, so I would say my district is, and I work in Covina Valley Unified, and I think that they have a kind of unique approach because they are doing a Coding for All initiative where they actually start in TK for that. So a lot of the students, by the time they've gotten through middle school, they've had some impact of computer science. That is still not systemic, and it's not every student, but it's coming. That every student is going to have some sort of impact with computer science. But for the districts that don't do that, well, how do you do that when students come in and they're freshmen and they know how to type and they maybe know how to do some stuff in G Suite, but they don't know computer science. There's what I like to think of computer science as, and I approach it as a pizza, right? Or you can approach it as a pie, or anything that you can cut into different parts. And what I think that students need to understand is it's not all coding. Coding is important. Coding is a very important part of it, but I think you have to understand all the aspects of it. That there's the internet, there's security, there's data, okay, and there's coding. And there can be even web design or those types of aspects. I mean, it can be broken up into multiple components. And I think sometimes we get focused on computer science as just coding, and it's not. Yes. It is one part. But to be able to understand all of it, you need to be able to understand what's going on the internet, what's going on with ethics, what's going on with data and security, so that they can get that big picture. And I think that is a good way to approach like an introductory computer science course, which I think that all students need to have sometime in their high school career.
I would definitely agree. And I love that you said it's more than coding, because coding is, as you said, very important. I mean, algorithms and programming is one of the 5 concept areas within computer science, from coming to us from the National Center. There's so much more. And
Oh, yeah.
so I like, yeah, and I like that you said that that's a great entry point for students because they're all kind of on that same level. If we're talking about the impacts of computing or we're talking about networks and the internet, or whatever it might be, I think that's a great way to go. I remember you talking in our previous Insight interview, I believe, or maybe it was before or after, about how computer science has really helped your English learners. I'd love to hear more about that.
Okay, so I think sometimes we get this idea with English learners that something like computer science might be a little bit too tough and too difficult because you have that higher level language that sometimes is needed for things like physics, science, things like that. But then we forget that computer science, I will really argue, is a lot like math. Okay, it's a universal language, and because it's that universal language, there's universal syntax. So Python, for example, in the United States is still Python in Germany, okay, and it's still Python in China, okay. It's still the syntax is the same, and even things like if we were to implement things like Scratch, or you were to do C or Arduino C or any of those things, the syntax is the same. Now, trying to relate that sometimes to students, it can be a little bit challenging if they don't understand English and you're trying to understand conditionals, but the syntax is the same. So I think when our English learners come in, we should be able to be able to jump right into getting them doing computer science. Now, here, just a case in point with something like math is, I had an EL student last year who came in into the 12th grade, okay, and had very little English skills, but he understood high-level math, and he did very well in his math class because he had those concepts and he understood it. So you can do the same thing, I would really argue, with computer science, and you need to, especially with our EL learners.
And I love that builds their confidence. I mean, if I'm an English learner and I go to my ELA class, my English language arts class, and I'm just struggling to translate and to read and all this, we want kids to feel successful in school. Success breeds success, and so putting them in a place like computer science, I think, is a great way to also build that confidence and that social emotional learning piece. So that's awesome. I love that. What would be your, I know you've spoken a lot about the need for computer science for all and all different grade levels and things. So what would be your comments to leaders? Like, why would you say, I agree that that's very important, but can you expand a little bit on why that's important for our kids? Like, for a leader that doesn't have computer science background, that doesn't really get this whole, I don't even understand coding so much. What's an abstraction? Like all these like Python, I don't know what that is. For people that are new to this, what would be your why we should do this for kids, even if I'm someone that doesn't really understand it myself?
Well, let's argue with the computational thinking piece, right? We need to understand it, and our students definitely need to understand how things work, right? How not only computers work, but how that big picture works, right? They need to be able to understand what is going on with the internet, and then how does data affect the internet? Okay, how do ethics affect the internet? Okay, there's innovations coming out. What are the societal impacts of that? Okay, so there's all these things that we have to understand when we're talking about computer science, right? And that's where computational thinking really comes in. You have to understand that big picture, okay? And then within just computational thinking, yes, we bring in creativity, communication, collaboration. We bring in all those other components.
Are you talking about the 4 C's? That sounds familiar.
Yeah, I think I was talking about the 4 C's.
Yes, but we, as you said, let's add another one. Let's add computational thinking.
Yep.
So a lot of what I heard could be quite interdisciplinary as well. right? And
Yeah,
so
very much so. Yeah. Yeah, computer science isn't, it should not necessarily be stuck to or isolated to a computer science class, right? Or to 1 hour of coding a week or something like that. But it can really transcend a lot of our other classes or other curriculum.
absolutely, yeah. And what for those of you that are looking for some guidance, the California computer science standards that are coming out are going to have an appendix and a chart that shows some possible connections between all those other content areas, specific computer science standards, because you're right, there's so many options for interdisciplinary work with computer science.
And our teachers need to be able to see those connections. Now, there's something interesting happening. I think you told me about the computer science standards. What's going on?
Oh yes, that's true. Let's talk about that. So today, actually today is a really big day. I know by the time this video is edited and comes out, it won't be this day anymore. But today is September 6th, and in probably a couple of hours, the State Board of Education here in California is due to formally adopt the California Computer Science Standards for the first ever computer science standards in the state of California. So yes, we are very excited about that.
Yes, we are. This has been a process that we've been watching. Some of us have been a part of. I was part of a panel to start looking at the framework to eventually go and create this document. So I'm super excited that we can have this.
And it is designed to be a guide. I mean, it's designed to be like the gold standard, so to speak, that other states can kind of follow, but as well. But yeah, it's exciting. Like there's a lot of good stuff in there, as far as not just this. Each standard has examples, clarification statements for those that don't have a computer science background. They're interdisciplinary in nature, so it's good. It's an exciting time. And what I like is what you were talking about, David, is that your district has gone all the way down to the primary level, all the way, I think you said to TK?
TK, yes.
Yeah.
In TK.
That's just great. And so the standards, which are based on the national standards, the California ones do go down all the way to kindergarten as well. So they're K-12, and they're designed to be accessible to each and every student in California. And so when you're talking about equity and you're talking about how great this is for your English learners, I feel that the state of California and other states are, there's already a few states that have adopted standards, and there's others that are following suit and that are in the process now. But that's really great for equity and for...
Oh, yeah. I think that's going to, in the following 5 to 10 years, we're going to see a real shift in the higher level computer science classes at the high school level, and then at the university level, we'll start being able to see that shift away from what the norm has been to seeing that equity and seeing not only more women in computer science, okay, but seeing just more racial and ethnic diversity within it as well, which is going to be really great.
Awesome. Absolutely. And also those from our own state. I mean, we've got Silicon Valley here in California, and we have companies that are hiring from overseas, and so the fact that we are finally, after a long journey, beginning this process to continue, by starting young like that, I think is going to be really exciting.
Yeah, that'll help. That will help a lot of our young people being able to get jobs, so the companies maybe won't outsource as much. We definitely want to see them. We want to see homegrown.
Absolutely. Absolutely.
Computer scientists. Yes.
I agree. I was just watching a video. It was a couple years old, but it was from Google, and Google had created this kind of like camp, internship type camp experience for, I think it was college freshmen. Mm-hmm. And the reason, and they were getting them interested in computer science, and the reason that they said they're doing this is because that it was so difficult for them to find qualified candidates from the area. And I thought that was really cool that they had this scholarship where they were bringing people in, and students that had never been exposed to computer science before, had not taken a computer science class in high school, were coming in and learning all these things and at Google headquarters. But the fact, what really spoke to me was, here's this huge company that's like saying we need people, and so it's so great to have computer science educators like yourself and others that are moving forward and trying to get these kids ready for that.
Mm-hmm. Definitely.
So one more question
Sure.
Before I ask for resources for those that are interested in learning more. So do you have students in your class, in your computer science classes, that are not interested in becoming a programmer, and if so, in other words, is this something that even if I don't want to go be a computer scientist, is your class still for me? Is that still valuable for all kids in that way?
Well, I have about, I would say when they first come in for my intro class, there's probably like 85% or 90% that have no interest in doing computer science as a career. They were maybe just put in that class by their counselor.
Okay.
Or like, okay, I didn't know what else to take, so I'm just and that is even sometimes the case with AP computer science principles. So which is kind of which is a great entry for AP computer science. Most of those students don't really want to go into computer science, but often what I see is, especially through AP computer science, is they get bit by the bug, and they get by the computer bug, which is that's a fun pun, I guess.
Very funny.
They get bit by the computer bug, and then they want to get more involved with it, and then they start taking it in college.
Yeah, I love it. I love it. And I would say that even those students, because you're at the high school level, but if we provide these computer science courses, or even integrate computer science into other subject areas, all the way down to, say, kindergarten, as you were saying, the computational thinking that they engage in is going to prepare them just for life in general, and for any college and career option that they choose. So.
Yeah, and and as kids go through their different grades, and we're talking about computer science as that whole piece, they're learning about things in social studies that are all ethical concepts and ethical ideas, and you keep bringing it back full circle, like, oh, this is involved with computers. How? What is the ethical implications? What are the societal implications? What are the future implications?
Absolutely.
Those things around the circle.
Absolutely. So if we have any of our viewers that want to learn more information about computer science and about some of the things you're doing, where should they go?
Oh gosh, there are so many different things out there, and I'm actually working on getting resources curated. So first, you can go to organiteched.com, because that's my website, and I'll be working on getting some good curated content in there for you. And other places to go, I think that code.org has great courses.
Great videos too.
What's that?
Great videos also to show why computer science is important.
Yep, it gives you that full concept. So if it's CS fundamentals or CS discoveries or their AP CSP content, I mean, they connect computer science to the real world and why it's important. I'm also a big fan of Tinker. Okay, Tinker with a Y, so TYNKER.com. Tinker is a very good resource. And then from there, you also there's Scratch 3.0. Okay, so you can get Scratch from scratch.mit.edu. And if even for your younger learners, if something like Scratch is kind of tough to start working with, you can work in, you can actually get scratch blocks and actually print out scratch blocks and put them together.
Yeah, I also like for those young students, CS Unplugged.
Yep.
I think it's .org.
Yep, and we forget that sometimes too. That CS things like coding, but doing it unplugged, and the unplugged concepts are very important for our learners, young and old, actually.
Agreed. Yes. All right. Well, I want to thank you so much for your time, David, and for sharing with us. This has been an awesome. It's been awesome just talking to you and hearing your passion for computer science and for our students and why it's important for them. Do you have any last closing words to inspire our listeners?
Computer science is for all, and all need to be doing it in some aspect or another. So if you're not doing computer science in your class, do it. Get involved with it. Look for resources and look at those standards, since we're going to have them now.
That's right. And actually, you could check out those standards on the CDE website very soon, but also at bit.ly/CS for computer science -SAC for Standards Advisory Committee. So those are a great searchable way to find them as well. So
awesome.
Thank you so much, David. And I want to thank all of you for viewing this Insight interview. You can see all Insight interviews at www.siteleadersconnect.org, and definitely be sure to follow David and all of those that are on our EduLeader database. Thanks, and have a great day.
Thank you.